Hi, my name is Patrick, and I started the company Algorithmica Technologies some 10 years ago to bring mathematical methods from the ivory tower into industrial application. And today I'd like to tell you about the intelligent soft sensor that we've recently developed, which basically covers two main application areas. One in which you want to measure something that you actually cannot physically measure, and the other in which you want to measure something that is either too expensive or too difficult to measure. So in the one scenario, you want to, for example, measure the efficiency of your power plant. That's not a physical measurement that you can perform using a device kind of sensor that you put somewhere, but it's really a calculation based on all the sources and sinks of energy around your plant, and this is something that can be computed. The kind of soft sensor that we provide would be the computational hub for that efficiency, taking into account all the various variables around the power plant. In a chemical environment, for instance, you might be thinking about an online analysis of the chemical composition of your product. However, in most cases, this turns out to be both expensive to install and expensive to maintain, as well as error-prone throughout the process. So a lot of chemical plants choose not to do this, but rather to take samples from the process, deliver them to an offline laboratory, and get the results back and type them more or less manually back into the database. But you can't do this very often, partly because of the logistics involved and the human processing at the laboratory, and partly because this is costly. So what we are offering with the intelligent soft sensor is to perform that online analysis in real time in your process, but via a computational methodology and not a physical measurement. The way that would work is that you have historical data during which you have obtained this via laboratory analysis, and we generate a mathematical model that correctly identifies the relationship between all the process variables that you already do measure physically and this result that you would like to measure but can't measure in some sense. And this correlation is being displayed then by a mathematical formula. In the end, it's a piece of software that has either the mathematical formula that we construct by hand in the case of the efficiency of the power plant, where we can actually really identify all the sources and sinks, and on the other hand, in the chemical analysis example, where we would learn based on historical data the relationship between process and output. Both are an equation that can be written down in a little piece of software that then functions as a soft sensor. The way it would actually work is that this program is connected to your DCS via an OPC connection. So via OPC, the entry variables are collected from the DCS, the computation is performed, and the result of the computation is being written back into the DCS just like a real sensor would. And that's why we call it an intelligent soft sensor, because we can extract that information from the historical database and create that equation fully automatically without the interference of human experts whose time would be hard to get. This is a piece of software you can very easily install, provide it with the historical data. It trains itself. It demonstrates to you that the training has been successful. That is to say, that the formula that is achieved actually correctly and precisely encapsulates the value that you want to represent virtually instead of physically. And then you can go ahead and immediately use it in real time in an update loop of fractions of seconds as you would a physical sensor application, and you wouldn't be able to tell the difference. So I invite you to try this out. It's a piece of software you can just download, try out in your plant, install. If you would like more information, please feel free to visit our website or to call us up to discover what kind of mathematical methods we employ. I've recently published a book called Optimization for Industrial Problems, in which you can read about all of the mathematical methods. We don't keep industry secrets. It's completely open there for you to see alongside with a number of case studies. The case studies you will also find on our webpage, where you can read what we have done for concrete plants, and you will also see there individual people for whom we have done this, so you can go check what we have done. Thank you very much.